Assalamu alaikum. This is chemistry 12th, and our today's lecture is the factors affecting the basicity of these amines. In our previous lecture, I have told you that that these amines are weak organic bases, and you know that a base is a substance which has got a tendency of donating electrons. So obviously, and the groups which are the, the presence of electron donating groups which increase the electron density of the resulting protonated amine, and they increase the basicity of the amines, and the groups and the electron withdrawing groups which decrease the electron density of this protonated amine, they decrease the basicity of these they decrease the basicity of these amines. And as I have told you that these alkyl groups, they are the electron donating groups, and we have got the aryl groups which act as electron withdrawing groups. So now these electron donating groups like alkyl groups, they increase the electron density of this protonated amine further, and thus consequently they increase the basicity of the amines. Now as far as the inductive effect is concerned, if we see that in case of primary amines, we have got one alkyl group which acts as electron donating group, and in case of secondary amines, we have got two alkyl groups which act as electron donating groups, and in case of tertiary amines, we see there are three alkyl groups which act as electron donating groups. So the magnitude of electron donation, it increases from primary to secondary and then to tertiary. So obviously this tertiary amine, it should be more basic than the secondary one, and the secondary amine should be more basic than the primary one. But the character order of this the strength of this basicity of these amines, these alkyl amines, is that we see that secondary amines, they are more basic than the primary amines, and primary amines in turn, they are more basic than the tertiary ones. You can see here in case of ammonia, we see Kb value, it is 1.8 into 10 raised power minus 5. Then in case of methylamine, we see that which is a primary amine, or we call it as aminomethane. The Kb value is 4.5 into 10 raised power minus 4. Then in a secondary amine like we have got dimethylamine, and the Kb value is 5.4 into 10 raised power minus 4. And in tertiary amine like we have got trimethylamine, the Kb value is 6.0 into 10 raised power minus 5. So from these values, we can understand, or you can understand that the secondary amines, they are more basic than the primary amines, and primary amines in turn, they are more basic than the tertiary ones. However, the actual order should have been that the tertiary amines should have been more basic than the secondary ones, and the secondary ones should have been more basic than the primary amines. But the order is secondary amines are more basic than these primary amines, and primary amines are more basic than tertiary amines. So there are a number of factors you can see here. This which affect the basicity of these amines. For example, we have got steric factor is one of the factors. We can see that the size of the alkyl group, it is more than that of the hydrogen amine. Sorry, the size of the hydrogen group, the size of the alkyl group, it is more than the size of the hydrogen atom. Thus it hinders the attack of the acid on the amine, and the basic strength decreases. Now the crowding, if we see the crowding of the alkyl groups, it increases from primary to tertiary, because in case of primary we have got a single alkyl group, and in tertiary we have got three alkyl groups. So obviously obviously this steric hindrance would be more in case of the tertiary amines, because in case of tertiary amines we have got three alkyl groups. Now as a result of this, the basic strength decreases. This is called the steric hindrance, and this steric hindrance is observed maximum in case of the tertiary amines due to the presence of the three alkyl groups. Now Now we can see that from this factor, as far as this factor is concerned, the citric factor, we can see that tertiary, these alkyl amines, they should be least basic than secondary, and secondary should be less basic than the primary ones. Then we have got another factor that is called the solvation of ions. Now this is the citric factor. From this citric factor, it is clear that the tertiary alkyl amines should be least basic because of this citric hindrance. Now solvation of, as far as solvation of ions is concerned, when amines are dissolved in water, they undergo hydration through hydrogen bonding. Now the protonated amine forms, it can form the hydrogen bond with the water molecules and thus releases the energy, and this energy we call it as hydration energy. Now greater the value of this, greater the extent of this hydrogen bonding in a protonated amine, greater will be the release of this hydration energy, and more will be the stabilization of the resulting cation, and consequently greater will be the tendency of an amine to change into cation. Now thus we can say greater will be the strength of the corresponding amine. Now the hydration of the protonated amine due to hydrogen bonding decreases. You can see in this is a primary amine. You can see here, in this case we have got there are three hydrogen these atoms, so the degree of this hydrogen bonding will be more because we have got three hydrogen atoms. Then we have got in secondary amines, like dimethyl amine, we can say we have got two hydrogen atoms. So hydrogen, there will be hydrogen bonding due to these two hydrogen atoms. Then in case of tertiary amine, you can see it, this is protonated amine. Now in this case, the hydrogen bonding will be, it will be least because we have got only one hydrogen atom in this tertiary protonated amine. But you can say this is a primary amine. When it undergoes, when it is treated with water, it undergoes this, it will get protonated. You can see this protonated, this is primary amine. Now in this case, we see three hydrogen atoms are there which form these three hydrogen bonds, so there is high degree of this hydration. So maximum hydration we can see in case of primary protonated this amine. Then in case of a secondary this amine, we can see here, when it is treated with water, it gives this protonated secondary protonated amine. Now this has got, in this case you can see two hydrogen atoms are there which form these hydrogen bonds with two water molecules, so the degree of there will be less hydration as compared to the primary amine. Then in case of tertiary amine, you can see here this tertiary amine, and when it reacts with water, it forms this protonated tertiary this protonated this amine, and we have got only one hydrogen atom in this case, and we see you can there is minimum this hydration. So minimum energy is released in case of this tertiary amine. Now and more and maximum energy is released in case of primary amine. So tertiary amine, so looking at this factor, that is this solvation of this ions, we can see that we can see tertiary amine is less hydrated than the secondary amine, which is less hydrated than the primary amine, and consequently we can say that tertiary amine is less basic. Now on the basis of the combined effect of this inductive effect, which is maximum in case of these tertiary amines, and solvation of the secondary amines are stronger bases than the primary ones, and primary are strongly basic than, is more stronger than these tertiary ones. So you can see here, this is a secondary amine, it is more basic than primary amine, and this primary amine, it is more basic than tertiary amine. So these are the factors which affect the basicity of these amines. This is for today, and thank you very much.